Let's solve different type question about homogeneous differential equation. First, how can we understand this is homogeneous? What we said, all power separate expression, in the separate expression, all power must be same. What's the meaning of this? X square, what's the power here is 2. Y square, what's power 2? X times y. X to the power of 1, y to the power of 1, 1 plus 1, total power here 2. All power are same, that's why this is homogeneous equation. What's the first step? First step was find dy over dx, that is derivative. To find dy over dx, let's send the x part to right side. You can send dy to right side as well, but now for that question, let's send dx to right side. On the left side there is 2x y dy. On the right side there will be, this is minus x square plus 3y square dx. To find dy over dx, let's send dx to left side and 2xy to right side. So it will be dy over dx minus x square plus 3y square over 2xy. And this is first, we found the derivative. Second step says that use substitution. Instead of y, write xv, and instead of derivative, write v plus x dv over dx. We will use this substitution, this transformation for homogeneous. Let's write here. This is our equation that we calculate. And dy over dx, we know that what is dy over dx? It's v x dv over dx equal minus x square. There will be no term for x square. We have to keep x square. Just we will substitute term of y. Instead of y, what we have? xv. So 3 instead of y, xv square. For this question, I want to remind, don't forget to use bracket. If you write like this xv square, this will be totally wrong. Instead of y, you are writing xv. So this square for all expression that you have. That's why xv square. Be careful about that. And over 2x instead of y, xv. So just we substitute term of y. Continue v x dv over dx. Here minus x square 3. This square for both of them. X square v square over 2x x square v. What's the important things? That the transfer, the part that you are using this substitution contain x and v always. The main things here, the important, most important things, the term of x must be common for all expression. What's the meaning of this? There is x square, there is x square, and there is x square. It means you make it correct. If, for example, if we had x cube, x square, it means you made a mistake. All term of x must be same for the part that you use this transformation, not for the derivative parts. Okay, so here same. So it means we can simplify term of x because our aim is to simplify term of x. V plus x dv over dx left side. And what we said, all x must be common. So x square is common factor. X square, and if we remove, there will be minus 1. X square, there will be 3v square over here there is x square put out times 2v. So you see x square is removed and v plus x dv over dx minus 1 plus 3 v square over 2v. So this is second. And what's the third part? Third part, obtain separable equation. How we obtain separable equation? We know that here there is dv and dx. So in front of dv there must be v, in front of dx there must be x. And so what's the meaning of in front of dv? There will be term of v. It means all v must be together. All v must be together. There is v, there is v. So all term of v must be together. That's why send this v to right side. So on the left side x dv over dx minus 1 plus 3v square over 2v here minus v. Equalize denominator by 2v and by 1. So x dv over dx here minus 1 plus 3v square because we multiply by 1, 2v minus v minus 2v square over 2v. Always you have to collect all term of x on the right or on the left side, okay, because this is important. X dv over dx here there is 3v square minus 2v square v square minus 1 over 2v. So what we say, in front of dv there must be term of v. Okay, let's send this dx to, I said x dv v square minus 1 2v dx. I sent this x. What we have, we know that in front of dx there must be x, in front of v there must be, in front of dv there must be term of v. So let's send this term of v to left side. That is 2v will be like that, v square minus 1 like that. It will be 2v over v square minus 1 dv. So x must be in front of the x, so send x like that. It will be 1 over x dx. Now you see in front of the x we have term of x, and in front of dv we have term of v. So this is separable. So if it is separable, we know that just take integral. So what's the integral? 2v over v square minus 1. So we know substitution method in the integration. If the derivative of denominator contains exactly in numerator, you can use substitution. What's the derivative of v square minus 1? 2v. Yes. And think, yes, 2v in numerator, that's why we can use substitution. Look, derivative of denominator in numerator, substitution. Don't forget this. So you will say u equal v square minus 1 and du its derivative 2v dv. Because why we put dv? We are taking with respect to v. So it will be 2v dv, 2v dv will be du. There is nothing. 1 over v square minus 1, v square minus 1 is u. So right side 1 over x dx. Let's take, what's the integral of 1 over u? Integral of 1 over u, ln u. Ln u, what is u? Is v square minus 1 and v square minus 1. Don't forget to put absolute value. It comes from logarithmic definition of logarithmic. 1 over x, ln x absolute value. And what we say about logarithmic function, if all expression in the separable equation especially, if all expression logarithmic function, what I said to you, instead of c, write ln c. Why? Because at the end we can remove all term of ln. So here ln v square minus 1, here ln x times c. We know that the formula, if we have two logarithmic function as addition, we can write in multiplication as in one logarithmic function as multiplication. This is important. So on the left side 1 ln, on the right side 1 ln, you can remove ln. Of course, instead of ln c, if you put c, again it will be correct. But to obtain a better solution as appearance in mathematics, it's for us better to remove term of ln. That's why we are doing this. So absolute value v square minus 1 equal absolute value xc. This is last result for us. But what was the fourth step? Fourth step says that instead of v, write y over x. That is resubstitute, because we know that y equal xv, y was x times v. So you have to write v and v equal y over x. Let's write last y over x squared minus 1 equal absolute value x times c. This is our last result. Don't forget to write x. Don't forget to substitute v for the last result. This is important because the equation depends on xy and the last result must depend on xy. This is a good question for homogeneous equation, and we remind you separable equation as well.